Like today, we're going to talk about angle relationships and triangles. My central question: what are some theorems about the measures of angles in triangles? Our learning goal: we're going to find the measures of interior and exterior angles of triangles. Some of that will be easy, some of that will be hard. And we're going to apply theorems about interior and exterior angles of triangles. Look at these key terms: auxiliary line, corollary, interior, exterior angle, remote interior angle, because why not? Right? But that's the first thing. The second thing for us was that at the time I was down here, so it was like the 1 week ago a year where I was. Okay, you've already written down some of this. Did you know about it? Probably. And I was like, hey, your dad's number. She was like, okay. We already wrote down the triangle sum theorem, just so we're clear on something, okay? Triangle sum theorem says that the sum of the angle measure of the triangle is 180 degrees. We are past that now, correct? Right? Everybody remembers that one from last week? What? Okay, I will. Okay, sure. Go ahead and write down the definition of auxiliary line. I'll talk about it from time to time. Okay? An auxiliary line. An auxiliary line is this dashed line that we add to make things look easier, to make you guys understand things. Okay? How about that? It is not necessarily part of the triangle. That's what you gotta understand. Okay? So in this example, line L, it's not part of triangle ABC. It's just there to help us visualize geometric principles. Triangle principles. Okay. We got it? To aid and approve. Figure to aid and approve. Tyler? Right? Next. Let's do this. Let's do this one. Okay? It says, use the diagram to find the measure of angle MJK. Put it in the back. Just simplify this a little bit. MNKJL. Here are the triangles. Here's one. In the back, can you guys see these angle measurements or not? Y'all can read the angle measurements. Okay, I want y'all to do that one for me. Try and find the measure of angle MJK. The angle measure of the triangle has to be 180. What? Yes, sir. What answer did you get? 76. Okay. I got 76. Anybody get anything else? What'd you get? 40 what? I can't hear you. 44. Okay. Let's start with those two. All right. There is a special principle that I used to have to talk about. When I used to have to talk about algebra, I had to do that a little bit, and analytic geometry. But there's a life principle here that you guys need to understand about some of these problems. I'm trying to find the measure of MJK. That is this angle measurement locked off. Okay, that one right there. Got me? That is the angle measurement I'm trying to find. Okay, I'm only given one of the angles in that triangle. In triangle MJK, I'm only given the measure of angle K, which is 104. That's a problem, right? That's a problem. But notice there's a key piece of information here. In triangle MNK, angle K is congruent to angle M in this triangle, in triangle MJK. Okay, so I got two different triangles with congruent angles. What are those congruent angles? What does that symbol mean? These are going to be the same measurement, right? Okay, so the principle that you need to hear, the life principle you need to hear is this, young people. There are times in life where you must use what you got to get what you want. Okay? So I'm going to use what I've got. I've got this information. I've got 88 degrees, 48 degrees, and that is enough to tell me what angle K is going to be. If I take 180, I subtract 88 and 48. Somebody do that for me in a calculator and tell me what that's 44. So that's 44, correct? This angle measurement is 44. DJ, if this angle measurement is 44, what is this angle measurement? Good. That means this is 44. Ah, Sensei. Now I've got two of these angle measurements, and I can use that information to pick up and answer questions. See it? See how that works? Okay, so I'm going to repeat this whole process. 180 minus 104 and 44. What do you get? 32 degrees, okay? So my answer here is 32 degrees. Weird? I'm sorry. That's the geometric principle. Every triangle has a total of 180 degrees amongst the three angles. Okay? All I did here was figure out what those angles were. I was given that this one was 88 and this one was 48. I had to subtract 180 minus 88 and 48 to come up with 44. I was also given this key information. Angle K is congruent to angle M. So once I found this angle measurement, I'm able to plug it in right here. And then I just repeat the problem. I took 180, because every triangle has 180 degrees in it. So this one would have 180, this one has 180, this one has 180. Okay? So since I now have two of those angle measurements, I can subtract 104 and 44 from 180 to get what my missing angle would be. Okay? We'll be doing it many times today. Here's what you need to write down about a corollary. A corollary is a theorem whose proof follows directly from another theorem. As a textbook definition, it is not really anything that you need to, I don't know, memorize. It's just a word we're going to be throwing out so much, corollary, that it's a good word to know in your vocab. Okay? Look at the corollary that we talk about here. A couple of them actually. First one is this. You don't have to write this down. Just listen. The acute angles of a right triangle are complementary. The acute angles of a right triangle are complementary. Complementary. does not mean the same. Not roughly. Exactly. 90 degrees. You have supplementary and complementary. Supplementary, a sum of 180. Complementary, a sum of 90. Okay? Right? Supplementary is the sum of 180. Complementary is the sum of 90. Check this out. Why is this always true? Here's why. How many degrees are in every triangle? A right triangle always has what type of angle? 90-degree angle. If I take 180 and subtract out that right angle that always is in a right triangle, how many degrees are left? 90. So no matter what, these two angles have to add up to be 90 in a right triangle. Okay? It doesn't matter if this is 1 and this is 89, if this is 45 and this is 45, 60 and 30. Okay? They always have a sum of 90 because the right angle eliminates right off of that 90 of those 180 degrees. Right? We'll play with. We haven't talked. We actually do a whole unit on right triangle next unit, so we got plenty of that. This one's not that bad. The measure of each angle of an equiangular triangle is 60. What does equiangular mean to you think? All of the angles are equal. How many degrees are in this triangle? Oh my gosh. How many degrees are in this 180? How many angles are in this triangle? Guess what 180 divided by 3 is? So amongst the 3 angles, there are 60, 60, 60. Okay? Right? We call that an equilateral triangle. We'll have equal angles and equal sides. Right? Equiangular. Equiangular. Guys, you don't have to write this down, okay? Oh my gosh, yeah, like every year they're like, okay, the inside or interior of a triangle is just like the interior of a home. Where would you paint interior paint inside the house? Where would you paint exterior paint? Outside. So yeah, Mad Dog, you wanted some life principles there, right? The other day you were at my desk, you were like, okay, well here's one, right? Don't go to Lowe's, buy exterior paint, and put it inside.
That's the only one you're going to do. You're going down to
Okay. Alright, so the interior is a set of all points inside a figure, and the exterior is all points outside the figure. Good deal, guys. Guess what else?
What?
The interior angles are the angles that are inside of the figure, and the exterior angles are angles outside of the figure. Thank goodness. I literally used to spend like 10, 20 minutes having to, and I might have to do it again this year sometime. Yes, with this class, because you guys are y'all are good classes. I will completely make fun of you. Alright, so here we go. You're right, it is pretty rude. Right? And it can get somewhat confusing because, right, y'all, 3 and 4, right, they're like next door neighbors, okay? 3's on the inside, 4's on the outside. Imagine you had somebody outside your home or place of living and they had a tent and they were outside the walls, right? You're number 4, you're number 3. Maybe you're number 4, they're number 3. Okay? Alright, write this down, please. Write this down, okay? Write the whole thing down, actually. Hello, Mr. Hobbs. Let me explain it real quick. Each exterior angle has 2 remote interior angles. Each each exterior angle has two remote interior angles. A remote interior angle is an interior angle that is not adjacent to the exterior angle. Eh? What is adjacent angle? Yeah, on the other side, right next to, right? Think about this, guys. You guys driving, y'all are like 15, 16-ish, correct? Okay, here we go. You're like 14 or whatever you are. Okay. Imagine these are parking spots. Okay, those are parking spots, right? Correct? I got me. Parking spot. Which two parking spots are adjacent to number 2? 1 and 3. How about number 3? 4 and 3. Is 1 adjacent to 3? Is 1 adjacent to 4? Okay. See adjacent? Y'all getting adjacent now? Okay. Adjacent. Right next to. Right next to means adjacent. So check it out. Angle 4 is adjacent to angle 3. I should say this the other way around. Angle 3 is adjacent to angle 4, correct? Which means that when I look at angle 4, there are two interior angles that are remote. They are not adjacent. What are they? 1 and 2. Oh, okay. I thought you said. Okay. All right. So we have what we call the exterior angle theorem. We have something called the third angle theorem. Okay. Here's what I want you to write down when you write down the exterior angle theorem. If you draw this diagram already, go ahead and draw the diagram, and then draw that expression equation right there. Go. I will read the definition for you. You will trust me on this. Exterior angle theorem says that the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. Just draw the diagram and write the equation. Okay? Just do that part. And make sure that you label this exterior angle theorem. Okay? For your third angle theorem, just the next one down here. Third angle theorem. Okay? I want you to write that definition. My third angle theorem is two angles of one triangle are congruent, two angles of another triangle, and the third angle is congruent. The magic number that is involved in all of this is 180. Okay? Magic number involved in all of this is 180. Please, over these next couple of examples, watch me demonstrate why. Okay? Because the triangle equals 180, and that means that we can go a million different ways with that. Okay? It's literally what it means. We've already done this one, actually. Okay? But I'm going to move on. I'll come back to it if you guys need it later. All right. Here we go. The measure of one of the acute angles in a right triangle is 63.7 degrees. What is the measure of the other acute angle? How many degrees are in every triangle? 26. How many degrees are in a right angle? How many degrees is one of the other angles? It is 26.3. Okay? See that? Guess what my magic number is?
180.
180 and chop off. Okay, that one's not bad. That's the first problem you'll by tomorrow. That'll be a piece of cake. Okay, they'll get tougher like this. Okay, they will get tougher. Please watch me put into practice the remote interior angle theorem. This thing that you guys just wrote down right here, correct? Let's see this. What we just wrote down. Look what this says. This says angle 4 is equal to the sum of angle 2 and angle 1. Angle 4 is equal to the sum of angle 2 and angle 1. What is angle 1 here? Okay, so that's 90 degrees. Sum means what? Angle 2 up here, or angle A is what? No. 2z plus 1. What is angle 4 out there? Okay, y'all see what I just did there? Okay, I've never been able to get students to do that. I don't know why. Okay, sure. It's the remote interior angle theorem. This is an exterior angle. You can see that, right? It's not inside the triangle, right? That is outside of the triangle. And because it's outside of the triangle, that angle measurement is equal to the sum of the remote interior angle. Well, I've got to take that principle and put it into an equation. I do that by saying this is 90 degrees, this is 2z plus 1 degrees, and that has to equal, together, added together, that has to equal 60 minus 9. Now I'll let the algebra take over. I can combine 90 and 1. I get 91 plus 2z equals 6z minus 9. You want your z's on the left or the right? On the right. 6z bigger than 2z? Is 6z bigger than 2z? Thank you. Then I want to move things this way. And if I move my z's to the right, what do I move to the left? Plus 9, plus 9. 91 and 9 is 100. 6z minus 2z is 4z. If I divide by 4, is that the final step? What is the final step here? Plug it in. Plug 25 in for z. 6 times 25 minus 9. Ooh, here's some PEMDAS for you. PEMDAS, what's the P stand for? Parentheses. I've got to take care of everything inside the parentheses first. E is exponent, so I have an exponent. No. M, multiplication. Can I multiply something? Okay, so that is 6 times 25. 150. I don't have anything to add. I'm sorry, I don't have anything to divide. I don't have anything to add. Subtract. What is my final answer going to be here? 141 degrees. Okay? Yo. Yeah. Yeah, this little line right here means that it's inside. That symbolizes that it's right there. Because otherwise we put it in about 4 point font and you would sit there and be like, okay. I won't as long as you don't say something like 2z bigger than 6z. Well, the whole triangle is 180. Why did I put 90? Right angle. The box. The red box symbolizes a right angle. So that's why it goes from saying right angle to 90 degrees. It's got to be automatic. Every time you see that box, you know, right angle. If you want to, do this. Just put 90. Just call it 90 degrees. Okay? Makes it easy. It's always going to be 90. You'll do it so many times in here. We have this thing that we just wrote down. I just told you to write this down. I hope you did. It's called the third angle theorem. What does it say? I'm going to read it off for you. Okay, here's your EOC type question for today. This is the type of question you can see on it. Okay? Let me just say this. What are my two different triangles here? Perfect, DJ. AFH, see that one? Right? That triangle. And GJI. And there's pieces of information that are very helpful on this diagram. In triangle FKH, angle H has one ring with it, and angle F has two. Remember what those mean? H. Yep. That means that in this triangle, FKH, angle H is congruent to, over here in this triangle, angle G. Okay? Let's see what that means. It's a hard diagram to look at, especially if you don't have colored pencil. All right? But that's what that means. My third angle theorem says that here's the third angle theorem, I'll make it very simple. Anytime I have two pairs of congruent angles, so I have two pairs of congruent angles here. Those third angles have to be congruent. Okay? They have to be congruent. And guess why that's true? The triangles always have to add up to be how much? So if I said this is 50, that means this is 50, right? If I said this is 40, that means that's 40. 50 and 40 is 90. What does that one have to be? 50 and 40 is 90. What does this one have to be? See why that's true? That's true because all of your angles of the triangle have to be 180. So this becomes really simple. 4y squared equals 6y squared minus 40 degrees. Right? Now, yes, if you want to know what happens next, I'll show you. Don't worry, we're not going to finish this problem. 16. Okay? Don't worry about finishing this problem. 16. So, subtract 6y on both sides. You get negative 2y squared equals negative 40. Divide by negative 2. You get y squared equals 20. Take the square root of 20, which is not a rational number. It's irrational. But if I plug in the square root of 20 here, I get 4 times the square root of 20 squared. What happens when I have a root and a power of 2? What do? They cancel out. So this becomes 4 times 20. And guess what that is? 8. Okay, that's why I told you don't finish the problem. No, I took all those out. Okay. But the principle I want you to see is the third angle theorem. Right?